Now let's take a look at the idea of the composition of inverse functions. We learned earlier this year that f of f inverse of x will equal x, and f inverse of f of x will equal x if the two functions are inverses of each other. And this is the composition of two functions who are inverses of each other, and the result will always be x. But for these inverse trig functions, it's only going to be true when the x value or the angle is in the restricted range of the inverse function or the restricted domain of the sine, cosine, or tangent. You don't really need to memorize that. You just need to know that it's not always true unless those restricted values are, unless x is within that. So now, when you go to do the problems, though, you can just think it through. So, I know this is true, but I don't really memorize that. We know that the inverse sine of the sine of x is x, inverse cosine of the cosine of x is x, and inverse tangent of the tangent of x is x, as long as x is in those restricted ranges of values. So let's take a look at some problems and see how we will handle them. So number one, actually the first three examples are going to be examples of x that are in the range of the inverse function or in that restricted domain. So in other words, we have the sine of an angle, and that angle is going to be between the angle negative pi over 2 to pi over 2. So inverse sine of pi over, or I'm sorry, inverse sine of the sine of negative pi over 6. So what's the sine of negative pi over 6? Well, we know that negative pi over 6 is an angle right here in the fourth quadrant, and the sine of that is going to be negative a half. So that means we're taking the inverse sine of negative a half, and of course that's going to equal negative pi over 6. Number two, the inverse cosine of the cosine of 5 pi over 6. So we know that 5 pi over 6 is over here in the second quadrant, and the cosine of that is going to be negative radical 3 over 2. The inverse cosine of that will be 5 pi over 6. And so you can see in the first two, we have the inverse sine of the angle comes right back to that angle. Inverse cosine of the cosine of 5 pi over 6 is 5 pi over 6, which means this last one, if it is indeed, like they said, the answer should be negative pi over 4, but we're going to make sure, and we're going to say this is going to be the inverse tangent of, and what's the tangent of negative pi over 4? Negative pi over 4, of course, is in the fourth quadrant, and the tangent of that is going to be negative 1. So we got the inverse tangent of negative 1, which of course is negative pi over 4. So all of those work nicely as being the composite of inverse trig functions. Now here is where x is not in the range of the inverse function. So now we have the sine of 3 pi over 4. So that means this will be the inverse sine of the sine of 3 pi over 4. Well, the sine of 3 pi over 4, of course, is going to be radical 2 over 2. And the inverse sine of radical 2 over 2 is just simply pi over 4 in the first quadrant. So because these angles in these last three examples are not between negative pi over 2 and pi over 2, then the inverse, well, I'm sorry, for inverse sine, they're not between negative pi over 2 and pi over 2. And for inverse tangent, they're not between negative pi over 2 and pi over 2. For the second one, inverse cosine, the angle would have to be between 0 and pi. And as you can see, it's not. So when we do this problem, the cosine of negative pi over 3, of course, is positive 1/2. And then the inverse cosine of 1/2 is going to be a positive pi over 3. So again, it's not equal to the angle on the inside. And the last one, the tangent of 3 pi over 4. 3 pi over 4, of course, is here. The tangent is negative 1. So we're going to take the inverse tangent of negative 1. And since the inverse tangent angle has to be, the answer, the angle has to be between negative pi over 2 and pi over 2. That will be negative pi over 4. So now, true or false, since the sine of 5 pi over 6 is a half, the inverse sine or arc sine of 1/2 is 5 pi over 6. And of course we know that is false, because that answer for inverse sine has to be between negative pi over 2 and positive pi over 2. So it can't be that. All right, let's take a look at example 2. A bunch of examples here. What's the arc sine of negative a half? Again, to me, I'm just going to say, okay, when is the sine negative a half? In this range right here. The sine's negative a half here, but that has to be a negative pi over 6. B, inverse sine of radical 3 over 2. Sine's radical 3 over 2. Here in the first quadrant, and we're going from negative pi over 2 to pi over 2, so that will be a pi over 3 answer. Inverse sine of 2 is undefined because you can't take the inverse sine of anything unless it's between negative 1 and 1. 2 is too big. The sine of no angle will equal 2, so that's not going to work. D is the arc sine or inverse sine of negative radical 2 over 2. That'll, of course, be a 45-degree reference angle down here, and that'll be a negative pi over 4. And for E, we got arc cosine negative a half. The cosine's negative a half over here. Remember, cosine has to be between 0 and, inverse cosine, excuse me, has to be between 0 and pi. So that is going to be 2 pi over 3 with that 60-degree reference angle there in the second quadrant, and between 0 and pi. So the last one, F, is inverse tangent of negative radical 3 over 3. That's a 30-degree reference angle. The tangent's negative. Inverse tangent has to be between negative pi over 2 and positive pi over 2. And so 30-degree reference angle's right there. That means it's going to be a negative pi over 6. And now we have 10 more examples. You should probably try these on your own and then see if you get them right. And so you could pause the video and see if you can do them. And, well, hopefully you paused and tried these, but here's how I would do them. We have on the inside inverse sine of 1/2. And I'm just going to go ahead and draw this down here and use for all of them. But this is negative pi over 2 to pi over 2. And, of course, arc sine of a half, that's going to be a pi over 6 angle. Sine of pi over 6 is a half. Number 2, inverse sine of negative radical 2 over 2. That's going to be a negative pi over 4. And the sine of negative pi over 4 is negative radical 2 over 2. Number 3, the arc sine of the sine of pi over 4. The sine of pi over 4 is radical 2 over 2. And then the inverse sine of that's going to be pi over 4. Again, if the angle's in that restricted range, then you can just put down the angle. But I like to make sure of it. This angle we know is not, so we got to be careful on this one. Sine of 7 pi over 4. 7 pi over 4 is, of course, all the way around to here. The sine is negative radical 2 over 2. But then the inverse sine of that is going to be negative pi over 4. As you would rotate down this way, you have to give an angle between, again, negative pi over 2 and pi over 2. So 7 pi over 4 won't work. Sine of 7 pi over 6. 7 pi over 6, of course, is right here. The sine of that is negative a half. And then the inverse cosine of negative a half, that's going to be at 2 pi over 3. Remember, for cosine, you have to be between 0 and pi. For inverse cosine, sorry. Number 6, the sine of 5 pi over 3. 5 pi over 3 is down here, 60-degree reference. The sine is negative radical 3 over 2. Then the inverse sine of that is going to be negative pi over 3. If you're going to be in that special range from negative pi over 2 to pi over 2, you'd have to rotate down negative pi over 3. to be in the same place. So the inverse tangent of -1, if we're going to be between here and here, that's going to be a -π/4, and then the sine of -π/4 is -radical 2/2. Number 8, the cosine of 7π/2. We have to rotate around, basically 1, 2, 3, 4, 5, 6, 7π/2 would be down here. Or you could say 6π/2 is basically 3π, which would take you around to here, and then one more. You're still going to be down here. Cosine of 7π/2, of course, is 0. And then the inverse cosine of 0 is π/2. Has to be between, remember, has to be between 0 and pi. Inverse cosine of pi, can't do it. It's undefined because you can't take the inverse cosine of 3.14. That's too big. You can only take the inverse cosine of a number between -1 and 1. The last one, the cosine of 2π/3. 2π/3, of course, right here, the cosine's -1/2, and the inverse cosine of -1/2 is 2π/3, because 2π/3, remember, is an angle in that special range for inverse cosine between 0 and pi.